Hey everyone, another day, another Leetcode problem. We're now going to look at 286 walls and gates. So what this problem states is that we are given an M into N grid, which is rooms, and each room can have a possible value, which could be -1, which means it's an obstacle, like a wall as you see here. It could be 0, which means it's a gate, and it could be infinity, which they've given us some value here, which basically means that it's empty and it's an empty room. Okay, so what we are asked to do is you can fill each empty room with the distance to its nearest gate. And if it's impossible to reach a gate, it should just remain as infinity. And as we can see in the input, they have given it like that, that these empty rooms correspond to the value of infinity. Okay, so if we look at this here, so we see that this is a gate and there is an empty cell here. So this empty cell to its nearest gate, this is just like, it takes 1 move. So they've given it as 1. And then from here to the closest gate, it goes it goes 1, then it goes, one step here, one step here, one step here. So those are 3 steps. But if it had gone like from here, then it would have taken 4 steps. So that's why this is the nearest gate, right? And then from here, it's 1 step. Here, it's 2 steps, and this is like 1 step here, 1 step here. So yeah, you guys get the idea. So from each empty cell, we're trying to find the distance to the nearest gate. So one thing we're seeing is when we talk about distance here from one cell to another, we have a unit distance if it's any direction, which is like in the 4 directions beside it. So first what we would do is, if I'm standing somewhere in an empty room, the thing I would do is I would look around to see that if right beside me there are any gates. If they're not, then I would increase the circumference, the area which I'm going to look at, and then I would look. So initially for this cell, I would look around to see, are there any gates? No. So I would see beside these, are there any gates? And yes, there is 1 gate over here. So the distance to this would have been 1, but it was impossible. There was no gate. So the distance from this to a gate was 2. So that's why we get the value of 2. And what does that actually mean when we're looking layer by layer by layer? That's a BFS. So we're going to do a breadth first search, and we're going to go layer by layer to look for the minimum distance, basically that circumference at which where I actually find the gate. So one thing that can be done here, which pops up to our head is, okay, fine, we'll start from all of these empty rooms and we'll just go on doing a BFS, but that's going to take a lot of checks again, because we'll have to see if it's an empty cell, if it's a wall, if it's not a gate, or if I was able to find multiple gates, then what am I going to do? There are a lot of conditions. So there's actually a clever way. So let's just look at that over here. So let's say that instead of starting from all the empty cells, let's say I start from the gate itself, okay? So the thing here is that we need to find the distance to the nearest gate, right? Which is also the distance of that gate to that cell. So if I take this position and I take this position and I keep these as my starting positions, and let's say they're at a distance of 0. Okay, and this is at a distance of 0, this is at a distance of 0. And I start a BFS from both of these. I go to the cells beside it. These are obviously invalid locations, so I go here. And it's an empty cell. So once I'm at an empty cell and I'd come from that gate, I know that this is the nearest gate to that empty cell. And I'll go ahead and just update this to distance plus 1. Right? So this distance can become 1, and then I'll have like a queue for this, right? So a queue would initially start with my position, so 0, 1, 2, 3. So it would have been 3, 0, and 0, 2 is where it would have started from, right? And once I reach this cell, I can go ahead and I can add that to the queue as well. And we are storing distances, okay? So I forgot that here. We'll store a distance. And now I've come to 2, 0. 2, 0 is at a distance of 1 from the closest gate. And then I would have come here and here, so I would have added 0, 3 was at a distance of 1, and then 1, 2 was also at a distance of 1. And then after I've finished these, I would come to 2, 0, 1. So 2, comma 0, which was at a distance of 1. And look at the neighbors here. So the valid neighbor was this one. And this is 1 incremented, right? So the distance here is 2. And that is a position of 1, coordinate 1, comma 0 at a distance of 2. And again, from these positions, I would go and I would check. I would keep on adding these. And yeah, so I would check if my cell is empty, my room is basically empty, then I go ahead and update it with that distance. And if it's not empty, then I basically don't want to check it. And we don't need a visited set in this because we're modifying the room's matrix, duty matrix that's given to us. And every time I find a valid value, I am updating it, right? And by default, by BFS, I would have reached it from my minimum position already. So that value would have been filled. And if it's filled already, then I'm not going to update it. So I am doing that, like making sure that I'm not repeating cells. So yeah, this is the intuition of it. So that's kind of a very nice trick here that we start from the gates itself. So let's look at this in the code. I think that would be better. Again, we can do if rooms is basically empty, we can go ahead and turn like this. We can return rooms itself. Yeah. And I want to check rows, columns. Okay, so length of rooms, 0. Okay. And now we've been given a few values, so I want to go ahead and kind of store those. So an obstacle, so I can call that a wall. I can store wall as -1, and my gate is a value of 0, and then I have empty, which is some value they have given here. Let's just copy that, store this so that it's handy and I can, like, my code is more cleaner. And then we want to start with Q, U, E, U, E. Yeah, that's our DQ for our BFS. And what we want to do is initially populate that with wherever our gates are, right? So let's go ahead for R and range rows, for C and range columns, if rooms of R comma C is equal to a gate, then I'm going to go ahead and append that to my queue, so I can go ahead and add R comma C. All right, so I have everything now to start my BFS with. All right, so let's go ahead and do while our queue exists. I want to go and check that cell. Sorry, one thing I forgot here is R comma C comma the distance, and the distance of the gates itself is 0, right? So let's go ahead and pop those values, and then let's look around for their neighbors to see where we can head next, right? So R, C, and distance is equal to top left, right? Okay. So once we pop that value, what we want to do is we want to traverse its directions. 1, 0, 0, 1. Okay, and then we want to go towards these directions and see if it's an empty cell, and we can populate the distance from there, right? So for delta R, delta C, I need coordinates. Sorry. Okay, so we wanna also check if they're in bounds. So 0 is less than 0 is less than equal to a row is less than rows, and column is less than columns, and we want to make sure that it's an empty room, right? So so rooms of row comma column is empty. See, this is where it comes handy. If it's empty, then I want to update that position, right? So I want to go ahead and do, what was that? Rooms of row comma column is equal to distance plus 1, because that's what it took to get there. And also I want to add this now so that I can do another like BFS layer from there. So q dot append row column and distance plus 1, which was the distance of that specific position, right? Yeah, and by the end of this, we should be able to return rooms. And let's just check if it's correct. Okay, I started from the gates, and then I started doing BFS from the gates. And for those positions, I checked if they were valid, and I checked if they were empty rooms. If they were empty rooms, then I was filling those rooms with the value of the closest distance to the closest gate. And then I was adding this as a new coordinate to kind of check further distances from. All right, by the end of this, yeah, that's working fine. Great. So yeah, this works fine. And let's just look at the time and space complexity over here. So what are we actually doing? So here we're going m into n, okay? And when we're looking at the queue, again, so this queue we're filling it with the values of all the gates, right? And the possibility could be that like every cell is actually a gate. So then this queue would have actually run like m into n times, and this is m into n, that's 2 times m into n, removing constants. So we'll do time is O of m into n. Okay, I wrote it over there, but yeah. And let's look at the space. So again, the space is because of our DQ over here. And that, again, at the worst case scenario, everything is a gate. So the maximum it's going to store is m into n different coordinates. But yeah, that's the solution for this. And I hope you guys understood. This is a really nice example for BFS and seeing it in kind of some variations. But yeah, happy coding, everyone.